This is the video where we start tying things together. I have strongly hinted at some stuff, but I haven't told you exactly just yet. So let's talk about something called the second derivative in a moment. But first, let's connect some concepts. So let's look at these statements. This first statement, a function is increasing if its derivative is positive. Yeah, that's what we talked about. Increasing means has a positive slope. It's going up. Okay. The derivative of a function being positive means the function's increasing. Positive derivative means positive slope. All right, that's fine. Let's look at the next one. A function's concave, up, if its derivative is increasing. Okay, sure, that makes sense. That's the definition of concavity from the last video. Concave up, if the derivative is increasing, we usually think about that as opening up. Well, let's connect those two things then. What does it look like for f prime to be increasing? That's this third bullet point. F prime is increasing when its derivative is positive, right? The derivative is also a function. F prime is a slope function, we say. It's the slope of our original function. F prime is a function that tells us the slope of the original one at any point. So it's also a function. It also could have a derivative. So combining all of that, f will be concave up when its derivative is increasing, and that's when its derivative is positive. So that brings us to the idea of a second derivative. See the definition below. So the second derivative of f is the derivative of the first derivative. So second derivative just means take the derivative and then take the derivative again. All right, so we write it f double prime like this. You could also see it with Leibniz notation. We really aren't going to use this notation very much, but there you have it. You could write it as y double prime, c double prime, etc. Okay, and in general, there are also third derivatives and fourth derivatives, and you could get up to 20th derivatives, but we'll hold off on that. I don't know if we really ever go much more than second derivative in this class. There's just no real reason to, but we'll see. Okay, so yeah, second derivative is just the derivative of the derivative. So to kind of talk about what this is, right, we have a new way that we can check for concavity. If the second derivative is positive, we have concave up. The second derivative is negative, we have concave down. Okay. And again, you can think about concave up as a happy face, concave down as sad face, or parabolas. That's not the technical definition, but it is useful. And again, be careful, sometimes you don't see the whole parabola. They're not actually parabolas, but I think it's just a good visual tool. So let's use this definition and see what taking a second derivative looks like. I'm not going to do some messy stuff right here. We got some messier stuff in the homeworks problems video for you. I just want to show you what it really looks like. Find the second derivative. I'm pretty sure we've already done example 3. I think this is example 4, but oh well. Find the second derivative and determine where the function is concave up and where the function is concave down. Check your answer with Desmos. So, to find the second derivative, what is the second derivative? The second derivative is just the derivative of the first derivative. So we need f prime first, right? First we find f prime. So we can do that no problem with the power rule. 7 comes down. Oops. And we subtract 1 from the exponent. And then we can just simplify like so. That's our first derivative. Well, to find f, the second derivative, you just take the derivative of the first derivative. Derivative of f prime is f double prime. So let's take the derivative again. What's the derivative of this? Well, same thing. 6 comes down, subtract a power, multiply the coefficients together. You get 126. X to the 5th, I think. 120 plus 6, yep. There we go, that's our second derivative right there. So we have now taken our first second derivative of this class. Ha! Doesn't that sound funny? Ha ha ha. Okay, determine where the function's concave up and concave down. So remember, it's concave up when the second derivative is positive. So where is this positive? Well, it's going to be positive when x to the 5th is positive. What kind of number do you raise to the 5th power to get a positive number? All right. So again, that's going to be when x to the 5th is positive, because multiplying by 126 doesn't change whether something's positive or not. Well, this is going to be when x is positive. So it's concave up on the interval from 0 to infinity. And likewise, it's concave down when the second derivative is negative. All right, which very similarly, same line of logic, going to be when x is negative. So from negative infinity up to 0, that's concave down. Let's check our answer. Let's graph the original function and see if it's concave up and concave down where we thought. 3x to the 7th. Where is my Desmos? There it is. All right, kind of hard to see this graph a little bit, so let's zoom maybe appropriately. Oh. Look, to the left of here, it's concave down. We have that kind of half of a negative parabola look. And to the right of 0, we see concave up. It's kind of like half of a positive parabola. It's opening up. The slopes are getting bigger, concave up. Here, the slopes are getting smaller, like the pandemic leveling off. In the pandemic example, not talking about the real world anymore. Who knows what's going on right now, whenever you're watching this video. But yeah, here we go. That's what we've got. So we checked it on Desmos. It checks out. Ta-da! That's concavity. That's how we can find it with the second derivative. It's just taking the derivative twice. So it's just more than double the work usually, because usually the second derivative is messier from the first derivative. Imagine like you have to use the product rule on the first derivative. Well, then the second derivative is usually really messy, because when you use the product rule, things get messy. Oh gosh. I'll try to not make things too terrible. And we have more practice for you at the end. Anyway, take it easy. Good luck. Bye-bye.